Initial. I was talking to someone on Discord to show something, if he's there. How do we do a U that is the unit vector across the x-axis rotated by an angle of theta? I guess theta is 0, means it's 1, so there must be cosine of theta. Theta 1, theta 2, here's a theta. And then this must be, well, yeah, sine, right? Theta. And V is then that rotated counterclockwise, so that would be minus this, comma, cosine. Shall I use square brackets? As in they are vectors, maybe. Yep, so I made a very nice image. I want to draw the U and the V in it. Can't type. And we begin actually with another connector, which I call W. There it is. Create text. V1. Where's the connector? Huh? What? This thing? Oh my god. Hold on. Testing. That's better, I guess. Thanks. Yeah. Oh wait, it's better turn this off. Everything is fine now. You see the orange thing here? That is a connector. Why? Because it has arrows left and right. And then we do a search in the source code and I can't find it back. Huh? It's this one. Open arrow twice, definitely this one. Okay. It is that one. So I'm going to draw another one. Draw a line between P1, I guess, and what is it called? Doesn't have a name, I think. P1R. To P and P1R. Might as well add a label to that as well. How the hell am I drawing it here and then the label I already did draw before? Let's move this down. Probably the other way. From this one goes from V1 to the let's say right, and this one must go to the left, or I could do a plus, but then just take the P1R here, I guess. Or not. Redefinition of, oh, now we have two of those. Yeah, it's so not it. Line at 1 from V. It's not it, not it. Calling it P1, P1R. Use of undeclared identifier, P1R. Then what was it called? V1R? Plot P1R, that's the only one we have. Sometimes I first create a P1R and then I create the plot thing from it. But you can also construct it directly. In that case you can just use the plot thing instead. It's derived from the more mathematical thing. P1R is a point. Plot P1R is derived from a point. So now we have also a connector here. So see, the beauty of this is that this let me, well, I don't know. Are you still, let me ask here this guy if he's already there or watching or not. Are you watching the stream? Or no time? Well, no viewers. Okay. Just going to add some arrows, I think. I can draw an arrow from this point to there. Are they from this point to there? Yeah, I think from this point to there. So from V to V1, that would be S. No, that's V. I already called this one V. Point V. Can I have a point V and a vector V? Hey, Abhimanyu. Oh, I made some progress. Very interesting progress, man. I have now my my figurine, and it's beautiful. I had not expected it to be this simple, actually. If you can still remember, that is, we had this. I had this README here. I was doing this thingy here with the alpha. No, I'm doing something worse. I'm trying to fit a line, trying to fit Bezier curves through data points. And I'll explain as soon as I have my picture again. But for Abhimanyu, I had this relationship here. Wanted to solve something, so we set some arbitrary variable, actually, v form variable, equal to the square root of v squared, w squared, because that's multiplied here, plus s2 minus 1 squared, because that's multiplied with the sign. And then because of the Pythagoras, well, this is just Pythagoras, right? So v squared equals w squared plus s 2s minus 1 squared. So you can draw it like this in a triangle. Yeah, that was arbitrary, just because you know, you see this pattern here. W times cosine and w times sine. And here plus or minus, and then again the same factor. But so it's like a rotated something. So we just fill this in, and then you have this relationship. So you have a new angle here, alpha. And then we can write that 2s minus 1 equals v times the sinus alpha, and w is v times the sine of cosine alpha, which then allows you to replace these variables with cosine and sine of alpha, respectively. And then you can use the trick of this formula, you know, this can be written as a single cosine of the difference between those angles. So then we call this. And then it turned out that V actually was equal to the distance between P0 and P1. And then I was like, I want to show that in the image so we can understand what the bloody alpha is. Okay, now I did it. I'll just show the picture. And it is absolutely stunning, simple or beautiful, I don't know. So I'll start here. So here you have P1. The definition of W is that you go from the vertex a distance 1 in this direction. So this is 1, you know, like this distance from 1 to 2, that's 1. We call that same distance along the symmetry line here. Then you end up from the vertex V to V1. At that point, at the distance 1, that's my definition of W. W stands for width. So this is the width of the parabola, but okay, I'm calling it W is the half of that width. So this is width, yep. Now it turns out that if you go that same width from P1 in this direction, and then parallel to the symmetry line down, you end up in P0. These two are this is always W. And this height here is the 2s minus 1. This is the triangle. So W squared plus 2s minus 1 squared equals V squared. V squared is just the distance between P0 and P1 squared. So I can walk over it and you can see that it's just, I just did draw in W and then draw a line from here to there. And then it turns out that this is an angle of 90 degrees, always stays like that. And then, of course, you can say, for example, if S equals 0, that means that, sorry, if S is a half, then 2S minus 1 is 0. So this length here, that let's say the wide difference between P0 and P1 is 0 at the moment. S is a half, which is the case. Well, more or less here. And then they are symmetrical left and right of the vertex. And this is W. So at the moment that P0 and P1 are symmetrical, left and right of the symmetry line, then their distance is equal to W. So that's another way to look at the width. Also, if S equals 1, then, so every time I hit the return here, it draws it again for a different S value. I'm increasing S here. So when S is 1, then P1 is in the vertex. So that would be here. And then I would say, yeah, S is 1, so 2S minus 1 is 2 times 1 minus 1 is 1. So the vertical distance between these two is 1. So P0 now is on this line. And of course, this is still W. So it's just the symmetry side of that one. This, you go just from the one up and then W to that side and you end up on P0. And likewise, when P0 is in the vertex, then P1 is there. That's the starting point. So we started again. Control C. So this is, I think this is S is 0. So at S is 0, P0 is in the vertex. And then P1 is exactly at this point. So W from the symmetry line and 1 distance of 1 up. So that's the Pythagoras rule. Super simple, well, in terms of image. So the alpha is this angle here. So alpha is here. Alpha becomes smaller, 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 smaller until it is 0, and then it becomes negative angle, and so on. Yeah, brilliant. So it's capturing that in my README file. Because no memory and stuff. I wanted to describe this mathematically, and for that, then I need direction vectors along the symmetry line. And I thought, well, u and v maybe, but then I already use v for the vertex, or maybe lowercase v. So in the unrotated case, then u is just the x-axis and v is the y-axis. I think this is correct. Yeah, absolutely. So it feels a bit strange to use a lowercase though for a vector. Yeah. Don't want to use v for both a point and a vector. What shall we use? I have to use uppercase. But this whole README is not talking about v yet. I'm just talking about vertex, I think. So vertex like that. The vertex. I'm not giving it a name. Okay, I'm going to use v here, why not? So then if you take the in product between P0, P1 with V, aka you do the projection of P0, P1 onto the symmetry line, then you get this 1 minus 2s. It's negative, it's not 2s minus 1, but negative of that because I chose to have it point upwards, the symmetry. But yeah. And then we have, of course, if you project it onto the other one, maybe we should start with that, because x comes first u. So project it on u, then you get w. I need to get the sign right. So I have my u points this way and v points up. And then we have here the vector from P0 to P1. So if you project that onto this axis here, this line here, that would be this vector points to P1 and the unit vector points horizontally, or I'll call that horizontal now. And then you get the dot product is this length and with a positive sign, which is W. So yeah. It's positive W because it's pointing that way and P1 is on that side. And that never changes, right? P1 is always W on that side. where is my ASCII art characters? Need this one. Well, this is not ASCII anymore. Drawing box art, character art. I want to have the last one as well. So projecting it onto U gives you W, and projecting it onto V gives you 1 minus 2S. And then you can make some special notes like where everything is when S has a special value, but maybe not that relevant actually. Now to answer Ultimate's question, what I'm really trying to do is I'm trying to fit a Bezier curve through data points where a Bezier curve runs from one point to another, parameterized by, say, a variable t, and then it is completely equal to the first point when t is 0 and equal to the second point when t equals 1, which is already the case. You know, that's why I'm talking about this rotated parabola in that way. So you have a P0 and a P1, and at the moment t equals 0, it's going to be here, and t equals 1 is going to be there. So hey, that looks like a Bezier curve, right? But then what is it going to do in the middle when t is between 0 and 1? That depends on other parameters. For example, in this case, it looks like this. But it could also be looking like this, which is definitely a different curve. It's, in this case, a different part of a parabola, which would be corresponding to a quadratic Bezier curve. Normally, I think, and that's where I also want to go, I have to talk about a cubic Bezier curve, which is different from a parabola. That's even more variation than possible. But I thought, let's try to begin simple. So now the next step is, now I'm going to analyze this out for 2 points. But there is an infinite number of parabola that I can draw through 2 points. And then the next question would be, what if I wanted to go through another point? So say we're drawing P2 here. Is then this parabola the only thing that goes through P0, P1 and that P2? Now, if it's not allowed to be rotated, then there's only one parabola that goes through 3 points. But in this case, we can rotate the parabola. So then, obviously, the shape of the parabola can changes as well. So there is a link between those things. I mean, between the rotation and the width. Trying to think of what that relationship is, and I thought I can draw a circle through P0 and P1. I think I'm gonna go rid of this circle because it has fulfilled its purpose. I want to have a circle that has a middle point exactly in between P0 and P1 and goes through P0 and P1. me start with that. Circle. Let's not do this circle. Draw a circle around the midpoint of P0, P1. Well, with radius the length of P0, P1 divided by 2. Yeah. How do I get the midpoint of 2 points again? Not even sure. I don't think I can add 2 points. Yeah, I just have to add half of the vector between the points to one of the points. That would work. And then I need at least this looks like a vector. It's not a vector, it is the length. Okay, so that is the length then. So we need that divided by 2. I need a vector from P0 to P2. Surely you have that already somewhere. Here's a line. I think this is a line piece. I could use this one. Okay, this is a create line from 2 points. What does that return? I just created it. Returns a line. No, it doesn't. Yeah, it does. Returns a line piece. That's what I want. The line piece has a length and a to and a from point. It's also not really a vector. I think I can create a vector from a line piece though. Might as well go straight to a vector. Let's see, undo your redo. It's kind of strange, I still don't have a vector. Okay. P0, P1. I'm gonna put that in instead of the P0, P1. It just should have been a vector to begin with. So this thing is nonsense. This is my V, really. Okay, I'm gonna call this len. It's only used here. Oh, it's only used there. Bullshit. Oh, don't even need it anymore then. I'm not even using it. Ticklish. Okay, where's my vector? Now I don't have a vector anymore. I'm just going to make a vector here then, called P0, P1, which is constructed from, and I would think that if this does not work, then what will? So we can construct a vector from 2 points. Yep, from 2. Totally should work. And then I can do plus a half that vector and just the length of that vector divided by 2. Yep, so now we have this circle which goes through P0 and P1, but also through P1R. So if I hit return now, you probably will see what I mean. This triangle exactly hits that circle. So this is the diameter of the circle. This is W, and this is 2s minus 1. And the variation is that you walk over that circle with the P1R. Now in this case I'm changing S, but what I also could do is not change S, not only change S, but keep P0 and P1 fixed, and then just run over the circle with this point, which then gives me WNS. So let's say I think I should, I mean that's what we start with. Ellen. Boys Bunny. So in principle, P0 and P1 are data points that I just start with. So I should keep them fixed. And then a variation that I can do is, well, I could just draw this circle, obviously, and then run with P1R, run over this circle, which then gives me W and S, both. But not yet the rotation of the parabola. So that's an interesting thought then. How many parabolas can I draw for any given point here? So we have then maybe the rotation around this circle as well as the rotation angle of the symmetry line itself. Maybe it's time to start a new program because I don't want to really throw this away, what I have now. But more or less do the same thing, but then keep P0 and P1 fixed. And then see what happens if you just change, say, this point. And I can even keep the rotation fixed. I have no idea at the moment what will happen. But I'm sure it will be very insightful. Note that H also lays on this circle. It's a really important circle. Note that, in case people that didn't know that, if you have a circle and you draw, and you have a diameter, so this line here goes through the center of the circle, then if you draw a straight line from one of those points to anywhere on the circle, and then from there to the other side, then that angle is 90 degrees. Yeah, so a line from here to anywhere on the circle, and then from here to there is 90 degrees. So this angle is 90 degrees because it's on that circle. This is 90 degrees, and therefore it is on the circle. Let me think what to do next. I think I should start a new program. Yeah. The helper point used to be helpful, but maybe now it's just confusing actually. Maybe I should not draw that. You have better ways to understand the curve than through looking at that point. So I'm going to comment this out. And then that one. And there must surely be another one. Yeah, this one. I should also draw in this, what this distance is, I think. Yeah, project it onto this one. So let's say it's positive when it's pointing up. So I should draw an arrow from. It's kind of annoying though. Maybe I should just point this the other way. I should just work with 1 minus 2s, I think. Or draw it down. Let's remove the dash from this line. I want to do some aesthetic stuff before I'm committing it. The line from between P1 and P0. Yeah, I don't even see it. Where's the line from P0 to P1? Oh, yeah. Draw a line through P0 and P1. Let's make this one solid. Can I just not do... Why is my line style? Is that really the... No, I have dashes for the line style. Well... Gonna make another one. It's too weird. Call this solid line style then. No dashes. And then the line from P0 to P1R. No, that's another one that nobody gets. Oh, here it is. I called it whoa. Okay. I'll call it P0 to P1R. And then we go from P0 to P1R. And I'm going to make it a connector. And I think that works immediately, but it should by default gives me in that direction arrowhead. For some reason, oh, that did work. It's pointing down now, yeah. So now, this is, I think it's just 1 minus 2s. Should add a label here. Hey, Devin. I already only have to plot one. Oh well. I think this works. I'll commit this. I'm slightly confused though. If I hit enter a lot of times, S becomes larger. So by now this is negative. Oh, but it is negative. No, it's not. Wait. What? Damn it. The length is not negative. Well, it's actually a signed length in units of the direction vector v, pointing this way. So it is negative because it's pointing the opposite direction of that one. I'll leave it this, I guess. So what I really should do is call this vector 1 minus 2s times the direction vector. Yeah, from here to there. Then you understand that it's pointing opposite direction, so that one must be negative. Can I make the font smaller easily? I think so, yeah. Of course I can do that. So suppose I want to do that here. I'll make it something... I don't have a dot in this font. I'm still using the Cairo toy fonts, so they don't have very much UTF-8 support besides ASCII. But let me change the font size a little bit. I'll just leave it like this. Commit it. Yes. But just to show how to do that, I should be able to do, say, blob, and then dot font size is something else. I don't know what the font size is right now. Let's try 12. It's definitely smaller. Nice small. And still the distance from the point is in pixels, I think. So that probably should be shifted a little bit closer. And that is called offset. So I can also say dot offset is not 10 pixels but 5 pixels. And then it's a little bit closer to the line. Yeah, I think it's a mono font. So if you want to have the distance between the... Okay, I can remove the spaces now. Maybe that's better. Well, does it look... I don't know. Does it look good? No, I don't think so. See how it looks like if you remove the spaces here. Yeah, probably better. Now, okay, enough play. Git diff stuff and status. It's about time to add this to the repository in this README. I guess it is. Means I have to have a look at it. I feel like I should make a picture and add it to the repository maybe. And I refer to the image from here. But if I do that, I'll have to draw in UMV as well. I don't feel like doing that. I'll just add this. Who cares? Commit everything. Right, so my next, maybe I should delete this one, I don't know what I'm talking about here. Is this short? It's more general about the... This is the cubic Bezier. So we have a not 2 by 2 by 3 by 3 matrix. I think. This looks very quadratic though. It's not cubic. No, it's still quadratic. Yeah, totally. I'm not sure if this adds anything, or if I want to keep it, continue it. Now this is a linear case. So if f of t is just a line, then if t equals 0, you're in P0, and if t increases, then you linearly move to P1. And by the time that it is t is equal 1, you're there. And then I guess the next version, oh no, this is still a linear thing. And now we have another one which is also linear. So now we have f of u, which moves linear between P0 and P1. And then f of v, which moves linear between P1 and P2. And then we make a g that moves between u and v. Sorry, between this point and that point. So fu and fv. Using the parameter w. Therefore, it is a function of 3 variables. So just like this one is some point times 1 minus u plus some point times u, and this one also minus 1 minus v and v. This one is running from the point fu times 1 minus w plus the other point fv times w, which you then can write out, and then you get a complex formula of 3 variables, and then you just fill in t for all 3 of them, and then you get the Bezier curve. So I guess you can do the next step as well, and the next, and then you have the cubic one. And I think the probably only interesting thing that you get out of that is the matrix equation, maybe. Yeah. I'll keep it, I guess. Now what? A new program. I'm gonna call it... I guess there's no better thing to call it than quadratic Bezier. Even though this one is also already about that. This was more about designing the Cairo window. And this one is more like an in-between project in order to... well, what we need to continue with the Cairo window, curve support. But the emphasis is more on quadratic Bezier curve. there's more to, well, let's make it 1, I guess. 1, okay, let's put this one at 3, comma, -2. Did I put P1 outside my thing? Barely I did. Put it at 3. Oh, but it's -2. Yeah, I meant, let's say, I don't know. I meant this point maybe. Let's put it here. 3 minus 5.5. Something went wrong. My curve is not going through P1. Yeah. Why not? Guess S is wrong. Maybe I got the sign wrong. Is that even possible? It should have been here. The P1R is here. It should have been there. In other words, it's... yeah, no. What went wrong? I think my intention was to have a horizontal line here from the center. And then we have a line from here and there, I think, yeah. And then what is W? Definitely should have used that as well. Maybe that is nonsensical. Might as well start like this, perpendicular to the symmetry line. So alpha being 0 means then that we end up perpendicular to the symmetry line, like there. And then we have this point and that line. What does that mean? What does that mean? Don't see it. So I have my alpha. I want the alpha to be rotating around this circle. I just sort of random value of 0. Now my signing W equals the length of that, the radius, I mean. The radius, of course, half this distance from P0 to P1. So I was assigning W to be the radius times the cosine of 0, which is 1. So W must be equal to this distance, which means that S is 0, which means that P0 and P1, S is 0, no, S is a half. 2S minus 1 is 0, or 1 minus 2 is 0. S is a half. It means that P0 and P1 should be balanced. So the curve must be like this, the parabola, through P0 and P1. Okay, S is wrong, definitely. If S was larger, this P0 would shift up there, or the curve itself would shift down until this point hits that point. Then it would be correct. And I think the error here is that I just have the wrong formula for calculating S. In fact, I have the wrong formula calculating W. I think what I calculated is the coordinates relative to the center of the circle, of that point on the circle. And then I randomly assign W and 2S minus 1 to that, which is nonsense. Thinking. Think. Okay, yeah, no, I'm not sure. There's probably a shorter way, but let's just go the hardcore root let the computer calculate way. Then that coordinate is what I want to have, I think, which is the coordinates that are calculated plus the center of this circle. I need a point which is the center of this circle. And then we calculate that, and then I calculate the rest from there. And then the next compile, it works. In other words, draw the circle around the midpoint. Let's make a point. Midpoint circle. What do I have? Everything starts with P0. Circle midpoint. Looks like center even. Yeah. is, well, that would be this. And then this is bullshit. I want to say that hey Tulip, I need more variables. Let's call this C D E F G H I J K. Integers. Let me know P Q Q. Q and R. Didn't really use that yet, I think. Sorry, this is bool again. This is R. And then we want to have the actual coordinates, so point on the circle. And then has the x coordinate of the center. Plus q. Maybe we should skip the whole q. Just go straight to that. Comma the center y coordinates plus this. And then W, because this remains. W is the it must be signed, I think, or W always positive. Blech. Yeah, W is always positive, I think. Extra complication. Well, it's always positive. It's easy in big quotes. That is then just the length of the vector. So I'm gonna make a vector and then the length of that. And that's a vector from this point to P1. Now this one is signed, so I could just use Pythagoras here. But that's not the whole story. I think it depends on alpha, really. So I should look at the value of alpha and then change the sign. But let's first start with the size, which is then, well, let's also use a vector. I could use Pythagoras, but yeah. That one would be the distance from there to P0, total length, which is then also positive. And I'm not sure when to make it negative, to be honest. So I'm going to use this, and then it's not true that it works after the next compile. But okay. I need to have another look at it. It's totally not true, even. It's like completely something went wrong here. Let's begin with, okay, I take it completely back. This is, that's so not working. Let's begin with drawing this point here. The point on the circle. Because by now, I'm starting to wonder where the hell is it. Auto plot that point. Plot dot create point. Dot point. Second layer. The point that we want to plot. And the plot style. The line style. Curve point style probably. What the hell is this cursor doing? I think GPT-4 is taking over. Yep, over there we have a point. Yeah, well, at least that's where I expected it. Horizontally. So alpha 0, so bam, there. I also want to have a point here in the center. Why not? Now I'm adding points. Give me a little success. Oh, I should be eating. Yeah, let's eat. Sorry guys, my life is a mess in terms of rhythm. I just get up at random times, I go to bed at very random times, I eat at random times, and if I keep doing that, I will never get it in order. It's already 8 p.m. actually. I should set the fixed time that I eat. And I'm doing it again. I'm just coding and coding and coding until my stomach says, I'm so empty. And I feel that, and then I think, oh fuck, I didn't eat yet. Post Bunny! Damn it. No, I'm just kidding. Can't place Post Bunny. She's on the other side of the world. The point is, however, I did make something. I did cook with 2 persons, so I still have half of it in my fridge. I just have to heat it up. I don't have to be there while it heats up, I think. To the way stirring it, shall I just drop it in the microwave? I think I'm gonna drop it in the microwave, yeah. And then I can continue coding until it's done. I'll be right back. Absolute random things. Fuck. What do you think? 5 minutes at 900 watts. It's gonna be burned on the outside and still cold in the middle. This should be good. Where's my center point? Yeah. Yeah, so that's the center point, and then we go horizontal, and then we get here a point, and then my W is supposed to be the distance from P1 to that point. And then 2s minus 1 is this distance. Well, I have to say the W seems to have made it. Because this distance kind of looks like that distance. Something is horribly wrong with the S though. Maybe it's 2s minus 1 after all. Or I just should change the sign in this case. I don't know. Let me see. P0 now on this side. I want it to be like that. Where's the actual P1? Oh my god. Oh wait, I know that. The actual P1. So if this is W, then if you go from P0, the distance W to that side, and then up, the actual P1 is like there. Which means that S is negative. Well, it should have been a half, probably. As good as a half, yeah. So the other way around. No, let's stare at the code. S. This should be quite a size. Yeah, it becomes super negative. Yeah, totally. So maybe this is 2s minus 1. I'm just gambling here before my foot starts peeping. S minus 1, absolutely random change there. Or maybe I should just do a negative there. Oh yeah, right. I told you I was not sure about the negative thing, so we could just put a negative there. And then this is very negative, and therefore this becomes large, and therefore S becomes large. I think now we have it. But nobody knows why, and we don't have it. Yeah, there is something else. Oh, I am getting it. Yeah, the rotation is also known. Theta is a function of this because this W must be perpendicular, of course, to the symmetry line. So you have to rotate the whole parabola. If you rotate it around P0, then that line, well, then until this hits P1, I think that's what you need to do. Yeah, this W is now not parallel to that W here. Yeah, you see also how I'm calculating the P1R is actually this point. But what it does, it goes from P1. Let me hit enter a few times. Oh, nobody knows what happened. Try that again. Oh, that's not good. Oh, there is no loop. No, yeah, whatever. So Yeah, this just the W of this is through the P1. Let's put W on below it so we can read it. Is it this one? I think so. That's better. You see it goes from P1, a distance W, perpendicular to the symmetry line. But we should end up there, which means that the symmetry line should be perpendicular to this little line here. Therefore, the whole parabola must be rotated. Yep, I think I'm going to have a look at my food, which starts smelling. I'll be back later, okay? I'm just going to stop the stream now.